What if I told you that scientists are trying to bring back one of the most legendary predators of the Ice Age, the dire wolf? Yeah, that's right. The massive, bone-crunching, deep-throated, howling creature that you might recognize as Ghost from Game of Thrones. Except the real dire wolf was even scarier, and now, thanks to modern genetic engineering, companies are trying to bring it back. Not metaphorically, literally, Jurassic Park style, but with fewer velociraptors and hopefully less running for your life. So what exactly was the dire wolf? Scientifically known as Enochion dirus, which means terrible wolf, this animal lived from around 250,000 years ago until its extinction about 10,000 years ago. It roamed across North and Central America during the late Pleistocene epoch and lived alongside other Ice Age megafauna, such as mammoths, saber-toothed cats, and even giant sloths. These beasts were larger and bulkier than today's gray wolves, weighing up to 150 pounds. With powerful jaws that could crush bone, think of them as the bouncers of the Ice Age. The dire wolf likely lived and hunted in packs, making it one of the apex predators of its time. They hunted large prey like bison, horses, and possibly teenage mammoths. But despite their intimidating build and savage skills, the dire wolf went extinct around 10,000 years ago. That time frame places its extinction at the end of the last Ice Age, during a period of massive ecological change and a drastic decline in large herbivore prey. This loss of large prey and increased competition from more adaptable gray wolves are thought to play a role in their extinction, and let's be honest, humans probably had a part to play in it too. What made the extinction particularly final was the dire wolf's evolutionary isolation. It had no close surviving relatives to carry on its genetic legacy, no second chance. A landmark genetic study revealed that the dire wolf wasn't even a true wolf and are considered more closely related to the African jackal. While they look closer related to the gray wolf, genetic sequencing on the evolution of the dire wolf showed it was a separate branch of the canid family, having diverged from modern wolves and dogs over 5.7 million years ago. That finding changed everything. The dire wolf is genetically more distant from gray wolves than wolves are from foxes. That makes cloning or direct gene editing far more complex than with more closely related extinct species. But let's not get ahead of ourselves. This isn't about cloning some fossil DNA and popping out a dire wolf puppy like a 3D print. In fact, we don't even have intact dire wolf DNA. Time and decay are a nightmare for preservation. They aim to do this by identifying key genes responsible for dire wolf traits, but how close are we really to reviving this Ice Age predator? And what does it mean to bring back something that nature itself has let go? Leading the charge is Colossal Biosciences. Based in Dallas, Texas, Colossal has become the face of modern de-extinction. It was founded by entrepreneur Ben Lamb and geneticist Dr. George Church. They claim to reverse extinction using synthetic biology and CRISPR gene editing. According to Colossal, the goal is not to recreate a perfect dire wolf clone, which is scientifically improbable due to the genetic distance and degradation of available DNA. Instead, their approach is to engineer a functional proxy, an animal that closely resembles the dire wolf in appearance, behavior, and ecological function. It has already made global headlines with bold plans to de-extinct species like the woolly mammoth, the thylacine, and more recently, the dire wolf. As of last year, 3 dire wolf proxies, Romulus, Remus, and Khaleesi, were born. They were created using DNA from a 13,000-year-old tooth and a 72,000-year-old skull and were sequenced into an edited gray wolf genome, which was then implanted into a surrogate domestic dog mother. This hybrid animal is the next best thing to a real dire wolf, one that could theoretically reoccupy the ecological role the species once played. However, some critics argue that calling these animals dire wolves is misleading. In fact, they say it's flat-out scientific fraud. Why? Because the creatures being created aren't actual clones or even genetically identical copies of dire wolves. They're modern animals with a few gene edits to resemble dire wolves in appearance and behavior. To put it bluntly, these are genetically modified dogs or wolves, not resurrected Ice Age predators. Think of it like someone giving a poodle a wolf haircut and calling it a werewolf. Impressive, but not exactly accurate. And if that's not crazy enough, researchers have also created mice that grow mammoth-like hair using mammoth gene sequences. So, what does the future of this kind of genetic engineering look like? We are entering a new era where genome editing, cloning technologies, and synthetic embryos could potentially reintroduce extinct traits into living animals. If successful, this could be used to help boost biodiversity and stabilize ecosystems that have been degraded by human activity. Projects like this may also unlock new medical and genetic breakthroughs, many of which will be useful in conserving endangered species. However, the idea of bringing back the dire wolf raises serious scientific and ethical questions. First, there's the issue of feasibility. While DNA has been recovered from dire wolf fossils, especially from locations like the La Brea tar pits, much of it is fragmented. Without a complete genome, it becomes difficult to know exactly what made a dire wolf a dire wolf. How much gene editing would be enough? Would the recreated animal behave the same way as a dire wolf? There are also concerns about ecological impacts. The ecosystems that dire wolves once inhabited have changed dramatically. Reintroducing a predator, even a proxy, could disrupt modern species and lead to unintended consequences. For example, what if the dire wolf looks at a golden retriever and says, lunch? So this raises questions as to would these engineered animals be released into the wild or kept in captivity? If they're bred and raised in labs, would they suffer physically or mentally due to their unnatural origins? Then comes the question of ethical priorities. Critics argue that while de-extinction sounds exciting, it's an expensive distraction from more urgent conservation work. Thousands of species are currently facing extinction, many due to human activity. Shouldn't we be focusing our efforts and funding on preserving what's still alive rather than reviving what's already gone? Colossal Biosciences and other proponents counter this by saying the two goals are not mutually exclusive. The same technologies developed for de-extinction, like genome editing, cryopreservation, and advanced reproduction techniques, can and do benefit endangered species today. For example, Colossal has pledged that its work on extinct animals will directly improve tools for wildlife conservation, gene banking, and assisted reproduction in critically endangered species. As we look toward the future, we must ask ourselves not just what we can do with genetic engineering, but what we should do. The effort to resurrect the dire wolf is not simply about reversing extinction. It's about understanding our place in nature, our ability to alter it, and the responsibility that comes with that power. The dire wolf, once a symbol of Ice Age dominance, has become a symbol of something else. The intersection of extinction and innovation. Whether it one day walks the earth again as a real animal, or only as a scientific aspiration, its story continues to evolve. In the bones beneath our feet and the data inside our labs, the dire wolf still has something to teach us. What do you think? Should we bring back the dire wolf, or should some species remain legends of the past? If you enjoyed this video, please like and subscribe to the channel to help me make more videos. And leave a comment telling us what extinct animal you would bring back if you could.